Okay, let's, for each problem, find the volume of the specified solid. So the base of the solid is the region enclosed. So there's two different functions in the area that's enclosed between them. The first function is y is equal to negative x squared over 9 plus 4, and y is equal to 0. So the x-axis. Cross sections perpendicular to the function are squares. So this is what it's talking about. This right here is your negative x squared over 9 plus 4, and then this function, the red line, is y is equal to 0. And then what happens is this is actually a three-dimensional shape, and the base is a square, and it's perpendicular to, even though I drew it on a slant, I would need like Desmos to show how they're perpendicular. So I guess I shouldn't have drawn it that way. However, so there's a couple things you'll need to note. You'll need to note these values, the upper and lower bounds, right? Well, how do you find those? Well, you take these two functions, this is equal to y and this is equal to y, so you set them equal to each other. So negative x squared over 9 plus 4 is equal to 0. Let's go ahead and add that to both sides. So 4 is equal to positive x squared over 9. We'll cancel that dividing 9 by multiplying 9 both sides. Well, now you've got a quadratic term, and you've got the x squared by itself. The undoing of x squared is taking square root, and remember, when it's a quadratic, you take both the positive and negative roots. So that's why we have negative 6 and positive 6 right there. All right, in fact, if you took negative 6 and positive 6 and plugged them back into this, you would get 0, both for negative 6 and positive 6. All right, now let's come back over here. So this is what the setup is, because remember here, let's come back over here. So it's the square that essentially we're having to integrate, right? And this side right here, how we arrive at that side, well, it's upper, subtract lower. So that's the side, how we arrive at the length of that side, and then you square it, right? We're gonna integrate that. So the sides occur when you've got negative x squared over 9 plus 4, subtract the 0. So f of x is equal the integral from the lower bound negative 6 to the upper bound, and then you've just got the sides. This thing right here represents this side. This function, subtract the horizontal line function. The upper, subtract lower. That's all we did here. All right, now we're going to simplify, because that subtract 0 doesn't really help anything. And now you have a binomial squared. And remember, with a binomial squared, it's 1, 2, 1. Right? So it's the first thing squared. Negative x squared over 9, negative x squared over 9 squared. And then it's 2 times negative x squared over 9 times 4. And then it's 4 squared. 1, 2, 1. So let's see what happens here. Yep, so negative x squared is x to the 4th. 9 squared is 81. And then it's 2 times, 4 times negative 1/9 is negative 4/9, but there's going to be 2 of them. So that's where we get negative 8/9 x squared. And then 4 squared is 16. We are not now ready to integrate, because we've simplified that as much as possible. So when we integrate, we're going to add 1 to the 4, which is 5. we're going to divide 5. Well, since there's already a denominator, 81 times 5 is 405. So we have x to the 5th over 405 for this first term. And then we add a 1 to the x squared to the 2 exponent, and then, which is 3, divide by 3. Well, 9 times 3 is 27. So that takes care of the second term. And then the integral of 16 is 16x. And all of that is from the lower bound to the upper bound. And then what you're going to do, all I did was rewrite it right there. Now we're going to plug in f of 6, subtract f of negative 6. So when you plug in 6 into this function, you get 256 over 5. We're going to subtract, when you plug negative 6 into here, you get negative 256 over 5. Subtract a negative is the same as adding a positive. So you end up with 512 over 5, or about 102.4. So then you rewrite that whole thing. F of x is equal to x to the 5th over 405 minus 8 over 27x cubed plus 16x from negative 6 to the upper bound upper 6, and that's what it equals. All right, that's it for this one.